So we learned that you can standardize a normal distribution random variable using this formula. Always when you subtract the mean and divide by the standard deviation, the resulting random variable, the transformed random variable, is a standard normal distribution, right? And how do we utilize this? First, suppose that you are interested in the CDF, the probability that the original random variable is smaller than a number, smaller than a value a. Then how can we calculate this? The idea is we have to standardize x. We know how to standardize it. But what you have to be careful here is that you have to standardize the other side of the inequality so that the inequality does not break. If so, like here, we are looking for, excuse me, probability x is smaller than a. So say x is smaller than a. But if you standardize x, then its unit will, like say, increases, like changes. So like, if you do not standardize a, then the inequality may break, may break down. So you have to match the unit as the original random variable. So mathematically, it's easy. Just subtract the same number and divide by the same number. Because the standard deviation is always positive, dividing by the positive number does not change the inequality. Therefore, the left-hand side of the inequality is the standard normal random variable z. But right-hand side is a new value. That means probability smaller than a, probability that the original random variable smaller than a equals to another probability about a standard normal distribution. But the value must be different, standardized in the same method with the same parameters. And now then, if you're interested in this, you have to calculate this. Then, if you know, we know how to calculate this. If you can calculate a minus mu over sigma, the standardization of the value, then put this into the CDF on Excel, and then it will return, Excel will return the probability that corresponds to this value. So this is how we do. Remember, you have to match both sides of the inequality. So it's it's another common place where students make mistakes. Keep this in mind. An example. Let's think about a new example. Here we consider tires. Suppose that a random variable x is the life of a tire in miles, in terms of mile, in the unit of miles. So when you choose a random tire and you measure how many miles it can drive before it wears out, right? And I'm going to assume that x, the random variable x, follows a normal distribution with the mean equals to 35,000 miles and standard deviation equals to 5,000 miles. By the way, I'm giving you standard deviation instead of variance because it's more convenient to use the standard deviation. Anyhow, so we know the distribution of the tire mileage, tire durability. However, we cannot calculate its probability. For example, we would like to calculate the probability of tires worn out before 40,000 miles. It's possible. Of course, it lasted longer than the mean. Anyhow, how many tires would be worn out before 40,000 miles? We are interested in this probability. we cannot calculate this probability directly. We are going to use the standard normal distribution. Ah, of course, if you use a program, it's easy to calculate this probability, but I would like to tell you the most fundamental method using the standard normal distribution. Anyhow, we are interested in this probability. Let's follow the same steps. Step 1, standardize both sides. Remember, you standardize x, which is easy. Anyhow, its result will be the standard normal distribution, but you have to standardize the right hand side too. Its counterpart has to be standardized in the same way, which is subtracting the mean dividing by the standard deviation. And we know the mean and the standard deviation, so calculate this. 40,000 minus the mean, which is 35,000, and divide by 5,000, which equals to 1. So that means the probability about x, a non-standard normal distribution, equals probability about a standard normal distribution. So non-standard probability is transformed into a standard probability. And the standard normal distribution's probability is known. You know how to calculate this. You can use Excel or you may use distribution table, and from the table you can easily find probability smaller than 1 equals to 84.134%. We have done this in an earlier slide, so I believe it's easy enough. Now try this. It's a same structure, has the same question, pretty much the same with different numbers. By the way, the parameters are the same. But now I'm asking you the probability smaller than 32,000. 32,000, and try this. Pause the video now and try it by yourself first and continue. Resume the video. I'm going to proceed in 3, 1, 2, 3. Okay, so same steps with different numbers. Probability x smaller than 32,000 and standardize x will be z, but standardize 32,000 will be this guy. 32,000 minus 35,000 divided by 5,000. It is minus 0.6. It's minus because 32,000 is below its average. So does not matter even if it's negative, minus 0.6. Then now plug this into Excel or the CDF of the standard normal distribution. So probability that a standard normal distribution smaller than minus 0.6 equals 27.425% according to Excel. So this step requires a table or program or a calculator. Okay, so it's easy. Using the clever idea, we may calculate any normal distribution using the standard normal distribution. And the similar question, but a slightly different question is when you have probability greater than something. So probability X tire life is greater than 30,000 miles. What is that probability? The idea is the same, but we have to have an additional step. Let's see. Standardize. Intuitive, straightforward. Standardize X result in Z, but standardize 30,000 result in minus 1. 30,000 minus 35,000 divided by 5,000. So one standard deviation below the mean. minus 1. And the problem here is probability, it's probability about a standard normal random variable. That's nice, but this probability is not a cumulative probability. Cumulative probability is probability smaller than something, but we have probability greater than something. So we need an additional step to convert this probability into a CDF, into the cumulative distribution. So it's easy using the complement rule. Probability greater than minus 1 equals 1 minus probability smaller than minus 1, right? And the last term, probability smaller than minus 1, can be found from the CDF of standard normal distribution. You find this from Excel. And if you enter minus 1 on Excel PDF, then you get 15.866. And then take 100% minus that probability is the probability we wanted. So 84% of tires last longer than 30,000 miles. That's what we learned here, what we can find here. So now it's your turn. Do this exercise. I'm the same parameters and same structure. I'm looking for the probability more than 37,000 miles. You have to follow the same steps and try it by yourself. I'm going to continue in the next video. Thank you for watching. Make sure you do this. Exercise is important, and you are going to do this kind of algebra many times in the following slides, following chapters. So please master the skills in this chapter.